Alrighty, so in the last video, I explained to you the difference between mean and median. Now they are both, again, they are both centers of a data spread. That means I can use either number to describe the entire data spread. How many goals do I expect the U.S. women's soccer team to score? What is the GPA of a student at IHS High School? These are all either mean or median. All right, so we want to know which measures should we use? Well, and that depends on the shape of the distribution and whether there are any outliers. What we want to look for is resistance. Remember, mean is not resistant to outliers. So if we look at the picture below, we show the mean and the median for dot plots with three different shapes. Notice how these two measures of centers compare to each other. The mean is always pulled in the direction of the skew. And the skew is the tail, by the way. What we like to say is mean chases the tail. Mean chases the tail. I don't know why this is acting up like this all of a sudden, but there we go. Mean chases the tail. So this data is called skewed to the left or left skewed. Again, because the tail, if we notice, the low end is on the left. There are less left values than there are right values. So the mean is pulled to the left compared to the median. Okay, the skew, we are skewed down here because there are very few high values. There are very few, or low values, I'm sorry. There's very few 13s, 14s compared to 19s and 20s. So what's ever going on with these quiz scores, these students didn't do so well, but everybody else did. That's my skew. Symmetric, roughly symmetric, we never say symmetric, we always say roughly or approximately symmetric. When we go up and down, mean and median are going to be very similar, if not exact. And on my left skew, mean, like it says right here, is less than the median. So pay attention to that. Right there it says it. So I could have just highlighted it. Mean is similar to median for this one. And then when we're skewed to the right, mean is going to be pulled to the right. Again, this is a right skewed because these 9 and 10 goal games are very different. So we don't normally score that high. So that 9 and that 10 drags the mean to the right. Okay? So mean chases the tail, and skew describes which side of the graph the tail is on. Is the tail on the left side or the right side? Alrighty, so let's look at this problem. Some students purchased pumpkins for a carving contest. Before the contest began, they weighed the pumpkins. The weights in pounds are shown here along with the histogram of the data. So here are the weights of the pumpkins: 3.6, 4, 9.6, 14, 11, 12.4, 13, blah, blah, blah. So to help us summarize that data, they made a histogram. They made our scale. On my horizontal scale is the weight of the pumpkin in pounds, and we are measuring in increments of 5 pounds, and then we are doing the actual frequency, not a relative frequency, go up. So we had 6 pumpkins that are greater than 0 but smaller than 5. We had 8 pumpkins that were 5 or greater but less than 10. 6 again that were between 10 and 15, etc., etc. And then down here, we had 2 pumpkins that were hecka large. Okay? So find the mean weight of the pumpkins. So remember, to find mean, oops, I can't spell sum apparently. We are going to find the sum of the weights. We're going to find the sum of our weights, and then we're going to divide that by the number of pumpkins. So we add up all the weights of the pumpkins, and it's very important that it seems like it's a huge waste of time, but I need y'all to get into the habit of showing your work on the AP exams, because when you hit that, they will grade you, especially when we take our free response questions. Does your work make sense? So please show your work. So we added up all the pumpkins and we divided by 23. And you can do that by just counting. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And a lot of times they'll tell you how many there are in the words. We divide, so the average weight is 9.935 pounds. So the average falls like in this bar right here. That's my mean. Well, find the median. So to find the median, put all the data in order. Put all the data in order. To find a median, you must put that data in order. There are 23 items, which means I am going to have 11 items. Then I'm going to have my median and 11 more. Because the way I do that is I'm going to do I'm going to take the number of items, 23 items. I'm going to add 1 and divide that by 2. So that gives me 12. Hold on a minute. All right, sorry, I had a brain fart. So that 12th means the 12th item is the median, because if it's an odd number, the median is always a data value. So if we count over 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, the 12th item is my median. Remember, if it's an even number, it'll always be a space. You can also say there's 11 items this way, and there's also 11 items that way. So my median is 6.6 pounds. Now, would you use the mean or the median to summarize the typical weight of a pumpkin in this contest? Let's defend our choice. All right, so if you look back at the histogram, you can see the histogram definitely has a skew. This is right skewed. Whenever you have a skew, use median as your center, because mean is affected by skew. Median is much less affected by skew. Median is resistant to skew. Median is resistant to skew, so use the median. So would you use the mean or the median to summarize the typical weight? Well, the histogram of the data shows that the harvest pumpkins 31 and 33 pounds may be potential outliers. So I have to address that skew. Because of the potential outliers, the median would be the better summary of the data. All right? So that's if you have a symmetrical distribution or approximately symmetrical distribution, mean or median is appropriate. If you have any skew, then use median. Median is a more resistant measure to skew. So notice I had to address the fact that I do have potential outliers. That is my skew. You have to say why you're going to use the median and then define that the median is used. So you could flip that around. You could say use the median because the histogram shows that my data is skewed to the right. And then I would say because of the 31 and 33 pound pumpkins, and then go from there. All righty. I will see you when I see you. Oh, please answer these questions, statisticians, 11 through 16 on your assignment. And then we'll hop right back and we'll be talking about range. Alrighty, so I'll see you when I see you, statisticians, and I hope it's soon.